Hi everyone, we are student of MS Mechatronics and Robotics and we have done a project in which we are controlling a robot at a distance location from the control computer, and we are doing it so using internet, and the robot is in a simulation environment in Gazebo, uh, and that's we are trying to do so. So let me explain you how are we going to do so. In order to do that, first of all we need to make our PCs onto same network, and in order to do that we are using VPN. We are using NYU's VPN so that we can bring both computers in the same network. We use these commands to bring them on same computer. I'll show you how. So I followed the instruction mentioned on the website, and then I chose NYU VPN all traffic that you can see here, because it asked me to choose either NYU VPN all traffic or NetRoute traffic. I chose all traffic so that I can use all NYU VPN services. And then I chose that. After that, it asked me asked my username and password. I have given that. And then in the second password, it asked me push. So I just put the push, and then I got a notification on my phone, and I clicked that, and then I approved it to connect my PC to NYU using my credentials. After doing so, I get an IP address that is 10.27.95.139 from NYU VPN. When I type if config on my PC, I got this IP address, and I asked my project mate to do the same task, and he also got a kind of an IP address from NYU VPN. The IP address that he got is 10.27.20.68. In order to understand the latency between both of the PCs, what I did is I learned the command ping, and I ping his IP address, and by doing so, I get the latency, like how a packet sent from my PC to his PC, how much time it takes. And I realized that it's quite varying data. However, the average is around 150 millisecond. And there is some packet loss, but that's fine. After doing so, we need to set ROS environment variables, because we are using ROS to control the robot and ROS properties. So in order to do so, in Geeta, that he is my project partner, so we set this parameters in his PC, export ROS IP and ROS master URI. We keep master PC, his PC, and what I'm setting the environment variables are export ROS IP 10.27, that is my IP address, and my the master URI is going to be same. What I need to do is I need to open a new terminal in which I'm going to use a ROS node which is going to connect to the network. I need to put this command, that is ROS IP, that is going to be mine, and ROS master URI belongs to Geeta because the master PC is Geeta. So that's what I did. And now in the second part of the video, Geeta will be explaining how he has launched the Gazebo node, and in the third part I'll be explaining how can I control a robot in Geeta's PC, which is he's sitting at a distant location.
Let's just come to robot part. We designed a robot in Fusion 360 and converted it into URDF file, where you can see here in sources and the job description. These are the files after converting into URDF, where these are the plugins and these are the physics which our robot has, and these are the materials, and these are the maps, and these are the launch files which are very important for launching our robot in Gazebo. Now let's just launch the robot. This is the command ROS launch teleop description space gazebo.launch, which launches our robot in a Gazebo environment. This is our robot that we have designed, which has differential motors, a LiDAR, a vertical slider, which may adjust our head according to the height, and a camera, and a LCD display. This is the environment that we are using for testing, which closely replicates our real life uses. And these are few dynamic obstacles and a person, which randomly moves in the prefix path. And when we set a goal to our robot, and it will automatically avoids the collision with the obstacle and generates a new plan at that instance and reach the goal. Now let's just try controlling our robot. We are able to control our robot, which indicates that the ROS nodes are taking perfectly fine and acting according to the commands. Now let's come into generating the map of the environment. You can see the environment of the robot here. And now let's start generating the map of this environment. Launch RViz, where you can see the robot, and it's in an open environment. And now let's launch the scan topic. And yet map to it, it takes the feed from the LiDAR and generates a map. Now for navigation part, we definitely need a robot and its map of the environment so that we can add a point in the map and robot autonomously reaches to the goal by avoiding the obstacles and generate a map. This is how we generate the map of the environment. And this is the map that we generated in the similar way.
So in the third part of video, I'm going to explain it. How can I get the image view from the robot and how can I control it? First of all, let's go to our terminal and let's see if we can access the parameters of ROS. So in order to do that, we type ROS topic list and we are able to get scan, TF and other parameters. Now, what we are supposed to do is now we have to run ROS run image view. You can see from this in this web page we have to run this program. We have to go to terminal. Let's go here. Yeah, here. So we have to type roster on image view. So we have to subscribe to image topic that our robot camera one image raw that is mentioned here, and we have to describe image transport as compressed. Why? So that we get we get the data as a compressed image, so it will consume less bandwidth. And now when I execute this command, you will see that I'll start seeing the camera image feedback from the robot. And now I'll just minimize this window and now I'll just open the Teleoptos keyboard. The initial velocity of Teleoptos keyboard is quite high, so we will reduce it around 0.14. That is fine. Now according to the camera view, I'm going to control it. Yeah, let's see. From I it's forward, so here the instructions are mentioned: I forward, comma backward, J left, L right. So yeah, let's do that. So when I press the I, it starts moving forward. Now I'm pressing L so that it starts going at the right direction, and now I'm able to control it. As you can see on the image, we are able to see the data of that. And now let's move somewhat forward. So we can see that we see the screen which says that China Science Technology Museum, and let's go forward. From J I'm going to left. I have pressed the left key. There is some latency, but that's fine. So see, the robot position is this, and now what I'll do is I'll bring the teleop control here, and I'll show when I move it, the robot is moving in the gazebo environment that we can see on Google Meet, as well as we can also see on the image feed which is coming directly from the robot on my PC. So we can see it can avoid obstacles pretty well, but it also depends on the obstacle, like how fast it is coming towards it. If it is too fast, then it won't be able to avoid it. But yeah, it is doing its job sufficiently, I mean, in a sufficient good manner. Or maybe, you can see it's making a path that avoids the obstacle. So we proved our point. Now, let's so yeah, this is the presentation, and this is our ROS navigation stacks is working. I mean, we have the map of the environment, and we just need to give the goal that where we need the robot should be there, and ROS automatically plans the path and make the robot go there, and it also avoiding the dynamic obstacle as we have seen in the example. Thank you.